Hello and welcome to the lesson video for 6.4, Properties of Special Parallelograms. Your objectives today are to prove and apply properties of rectangles, rhombuses, and squares, and we will use properties of rectangles, rhombuses, and squares to solve problems. Once again, make sure you've already completed the vocabulary both in your note packet and your vocab book, and we will begin with this warm-up. If you've already completed it, you may continue through the presentation without pausing. Otherwise, pause to give yourself time to work out these problems. Alright, hopefully you've had a chance to answer all four. Here are what we should get. Solving for x, number 1, x is 4. Number 2, x is 47. Now for 3 and 4, we're using this diagram to give us these measurements. CD, you would set 2y plus 8 equal to 5y minus 1, so CD is 14. And on number 4, these two should add up to 180 degrees. So we add these up and solve for x and plug it back in to find the measure of angle C, which will be the same as the measure of angle A, since this is a parallelogram. Measure of angle A and C are both 104 degrees. Alright, we're going to learn 3 new vocabulary terms as well as theorems and postulates that go along with those. Rectangles, rhombuses, and squares are our 3 special parallelograms. First, we talked about a special quadrilateral called a parallelogram. A second type of special quadrilateral is called a rectangle. A rectangle is a quadrilateral with 4 right angles. That is our definition. Now, there are many other characteristics of rectangles, but we will look at this as our definition. If it's a quadrilateral with 4 right angles, then we know it's a rectangle. And here are 2 properties of rectangles. If quadrilateral is a rectangle, then it's also a parallelogram. All rectangles are parallelograms, so we have this as our shorthand. Also, if a parallelogram is then a rectangle, then its diagonals are congruent. If it's a rectangle, then diagonals are congruent. Because it's a parallelogram, we also know diagonals bisect each other. Since a rectangle is a parallelogram, a rectangle inherits all the properties of parallelograms that you learned in lesson 6.2. So let's look at example 1a. We're going to use these properties in a craft application. A woodworker constructs a rectangular picture frame so that JK is 50, JK is this left side, and JL is 86. The diagonal is 86. We want to find HM. Well, we're told it is rectangular. That means this is a rectangle. So since it's a rectangle, we know the diagonals are congruent. So to find HM, part of the diagonal, we're going to say that JL and KM are congruent, so their measures are equal by definition of congruent segments. So they're both 86. Now, because it's a parallelogram, diagonals also bisect each other. So HM is going to be half of the full diagonal KM, or half of 86, which is 43 centimeters. Now, in the other part of example 1, we're using a similar diagram here. We have a rectangular gate. It has diagonal braces. Now, the first part you'll notice is to find HJ. So this first slide, that's what we're going to do, is find HJ. And then I'll show another slide finding HK, which we're supposed to find. HJ is the top side of this rectangle. Because it's a rectangle, we know it's a parallelogram. And parallelograms have opposite sides that are congruent. So we know HJ and GK are congruent. That means their measures are the same, so HJ measures, oops, one too far. HJ measures 48 inches. Now the other part, finding HK, relies on the fact that the diagonals are congruent in a rectangle. So HK and JG are the same. And in a rectangle, because it's a parallelogram, diagonals bisect each other. So JL and LG are the same length, and JL is 30.8. So HK is the same as JG, which is 2 times JL. So we're going to take 30.8 and double it to get the full length of a diagonal. So HK and JG, both diagonals, are 61.6 inches. Let's take a look at another type of special quadrilateral called a rhombus. A rhombus is a quadrilateral with 4 congruent sides. As long as all 4 sides are the exact same measurement, we call it a rhombus. And here are some properties of rhombuses. First of all, if it's a rhombus, then it's a parallelogram. Because it's a parallelogram, we can come up with these two conclusions. If a parallelogram is a rhombus, then its diagonals are perpendicular, and they bisect each other because it's a parallelogram, but this theorem just focuses on the diagonals being perpendicular. That means they form right angles. And if it's a rhombus, then the diagonals bisect a pair of opposite angles. So in this case, angles 1 and 2 are congruent, and angles 5 and 6 are congruent. And in fact, because it's a parallelogram and opposite angles are congruent, 1, 2, 5, and 6 are all congruent angles. The same along this other diagonal. 3 and 4 are congruent, and 7 and 8 are congruent, and all 4 of these in blue are also congruent. If it's a rhombus, each diagonal bisects a pair of opposite angles. Like a rectangle, a rhombus is a parallelogram, so it inherits all the properties of parallelograms as well. So in example 2a, we're going to use some measurements here to find, first of all, TV. So we're going to find the length of TV, this side, by remembering that in a rhombus all sides are congruent. So even though we're not given an expression for TV, WV and XT, which are congruent to the other sides as well. So WV and XT are equal because of definition of a rhombus. So I can substitute the given values and solve for B. B is 1.3. So we're going to substitute that value and plug in what we know for B. So TV, as well as all the other sides, is 7.9. All right, let's take a look at the other portion of example 2a. We are to find the measure of angle VTZ. Now, if you look at VTZ, we are given XTZ as 5a minus 5, and we're also using another expression for a in VZT, this angle here. Now, in order to know what VTZ is, we need to remember two things. First of all, the diagonals of a rhombus are perpendicular. But because a rhombus is also a parallelogram, the diagonals bisect a pair of opposite congruent angles. So XTZ and VTZ are going to be the same measurement. So 5a minus 5 can also apply to the angle we're looking for. So to find the value of a, we need to remember that this is a right angle formed by the diagonals. Because it's a rhombus, the diagonals are perpendicular. That means VZT is 90 degrees. So I can substitute the values that I know, 4a plus 20 equals 90, and solve for a. If we subtract 20 from both sides and divide both sides by 14, a is 5. Now we're going to take that value and remember that each diagonal bisects a pair of opposite angles. So VTZ and ZTX are equal. So VTZ is 5a minus 5. We can substitute 5 for the value of a. 5 times 5 is 25, minus 5 is 20 degrees. Let's take a look at example 2b. In this example, we're supposed to find CD and also the measure of angle GCH. But first, let's find the measure of CD. We know that CG equals GF by definition of a rhombus. We have then, by substitution, 5a equals 3a plus 17. We just need to solve for a. A is 8.5. If I plug that back in, all the sides are going to be 42.5. That means CD is also 42.5. All right, we need to now find the measure of angle GCH if the measure of GCD is b plus 3 and the measure of CDF is 6b minus 40. Now, because of our definition of a rhombus, GCD and CDF are corresponding angles of a parallelogram, so they must be supplementary. So we're going to substitute the values we have. If we solve this equation for b, divide both sides by 7, b is 31. Now we're not done with that. We have to take that value and plug it back in to find the measure of angle GCH. remember this. Rhombuses have diagonals that bisect a pair of opposite angles. So 2 times the measure of GCH is b plus 3. b was 31. So if I take that, add 31 plus 3, and then I divide both sides by 2, GCH is 17 degrees. Our last type of special quadrilateral is called a square. Square is a quadrilateral with 4 right angles and 4 congruent sides. So it is both a rectangle and a rhombus. So it also has the properties of all. Rectangles, rhombuses, and squares are sometimes referred to as special parallelograms. So in our final example, we are going to verify the properties of a square by showing that the diagonals of this square are congruent, perpendicular, bisectors. We're going to show those 3 things. So the first thing we want to show is that the diagonals are congruent by showing that they both equal root 122. We're going to use the distance formula for that. Then we're going to show they have the same slope, or opposite reciprocal slopes, so that they are perpendicular. And then we're going to show that they share the same midpoint, meaning they bisect each other. So we're going to show all 3 of those things. First, we're going to use the distance formula to show that SV, that's one diagonal, is root 122. Then we're going to use the distance formula again, plugging in your coordinates, for TW. Why don't you take a moment to find the length of TW, verifying that it's also root 122 by plugging it into your distance formula. We should get something like this. Since they are both equal to root 122, they are congruent. There's step 1. Step 2 is to show that they're perpendicular. We do that by showing that they have opposite reciprocal slopes. So why don't you find the slope of SV and the slope of TW. You can either use rise over run to count that on your graph, or you can use the slope formula and then check our answers. The slope of SV should be 1 over 11. Negative 3 minus negative 4 and 6 minus negative 5 gives us 1 over 11. The slope of TW is negative 11. We get negative 11 over 1. These are opposite reciprocals of one another, so they multiply to give us negative 1. So SV is perpendicular to TW. Lastly, we want to show that they bisect each other. We do this using the midpoint formula. So I want you to find the midpoint of SV and the midpoint of TW. Pause the video if you need more time, but you should get that they are the exact same coordinates. All right, this midpoint of SV is this, 1/2, negative 7/2. The midpoint of TW is also 1/2, negative 7/2. Since SV and TW have the same midpoint, they bisect each other. The diagonals are congruent, as we showed in step 1, perpendicular, as we showed in step 2, and now bisectors of each other, as we showed in step 3. Alright, before we finish this video, make sure that you take a look at the quadrilateral's Venn diagram. This is the Think and Discuss question 3, I believe, of the following lesson, and write the missing terms in each of the unlabeled sections. Alright, then you're going to write a definition of each term. If that's not the Think and Discuss, and I'm mistaken, go ahead and do your best to fill in that diagram. Otherwise, ask any questions you have during class time.